when Liz asked me to talk, she was keen, I think, to get something different to Adam's presentation, something that would sit alongside it, but create quite a different perspective. So hopefully I'll be able to do that. There'll be some themes in common, some that are different, and some that will build as well into some of the things you're going to hear about over the rest of today and tomorrow. And really I'm coming at this from the perspective of the current enthusiasm for big data. Big data is everywhere, we are told. It's transformative, it's disruptive, it's any other big words you might like to think of. But actually, how much has really changed in gaining insight, in turning information into knowledge, and actually achieving your objectives, whatever they may be in science or in business? Big data is just a tool, and sometimes we get a little too caught up in the bigness of it and forget that there's a point behind it. So I'm going to look at three main areas over the next 15 to 20 minutes. Data speaks, data talks to us, data tells us things. Then look a little more at this idea that size matters, the bigness of big data. And then I want to touch on something else, which I think is going to become a very important issue, certainly in the commercial world, but also in the academic world as we move forward. This notion of personal data, privacy, and perhaps most important of all, trust. So let's get going. Data speaks. Data, you may have noticed, is cool right now. Everyone apparently wants to be a data scientist, whatever one of those is. Everything is data-driven, from science and journalism to decision-making and even policy shaping. Even government looks at data now. But actually, we've always gathered data. We've always used data to craft hypotheses, to win arguments, and to support even the most outlandish of theories. In 1854, there was a severe cholera outbreak in London. Hundreds of people died. At the time, pretty much everyone thought that cholera was caused by bad air. You breathed it in and dropped dead. John Snow, who was a physician at the time, didn't believe this, and I'm sure a lot of you will have seen this example before. He didn't have access to an electron microscope, so he couldn't look at cholera and see that it's actually a key ingredient in marmalade. He needed to look more broadly than that. He needed to go back to first principles and try and understand what was going on. So he drew a map. He plotted the deaths. Each of these little blobs is someone who died of cholera in this part of Soho in London. He plotted 12 water pumps in the area. And I know there are only 11 there, the 12th will appear in a minute. And there was a very clear link between the deaths and one pump. They're all clustered around that one pump. They removed the handle from the pump and the outbreak stopped. Magic, or science, or something. Snow did actually admit after the fact that the outbreak had probably peaked and was probably going to come to an end anyway, but he had established there was a link here and went on to do some quite interesting things with that information. So another example, staying small, these are neurons in the retina, and it was the closest sort of scientific-y, microscopy type image I could find to that one. This is my network on LinkedIn. This is 1,000 connections or so. They connect me to 11 million connections of connections and connections of connections of connections. And each one of those 11 million individuals influences what that picture looks like. Inadvertently crowdsourced art, proof that I am the centre of the universe, as my wife says I sometimes think, which I deny. All I actually did was provide the labels. LinkedIn generated the clusters. LinkedIn worked out those individual groupings and said, what are they? What do these mean to you? Who are these communities? So I added the labels so that I know who these people are. And you can see that's sort of the semantic web community, big one. People in the European Commission, JISC and its assorted associated projects and things, the cloud computing world, and I have absolutely no idea who what the connection is between these purple blobs that sort of spread across the map. I do not understand what that group is at all. But it's fascinating to look at this and to explore it, to understand my network, to understand my connections to different professional communities and the ways they've changed. If I were looking to actually extract real value from this, I might identify some of the influencers, some of the big blobs, or some of the ones at connection points, and buy them coffee, and send them Christmas cards, and do all the stuff I need to do to make those influencers more aware of me. You can also see people jumping from one world to another. So that one in there, for example, is a man called Richard Wallace, who was at Thales and is now at OCLC. And you can see he's moving away from the Thales blob towards the library blob, but he's still orange. He's still a Thales person, according to LinkedIn. Don't tell his boss. So move on again, another example of data telling stories, and more bugs and germs and viruses and things. And this is a topical one. This is influenza. More specifically, this one is avian flu, but hopefully that's not here. And this has been in the news over the past few days. It's actually an old project at Google Flu Trends, but just in the past few days it's been newsworthy because of the severity of the flu outbreak in the States. And this is simply generated from all of the search logs that Google has. All those people out there who start sniffing or coughing or feeling a little flushed, who start searching Google for flu and flu symptoms and flu medicine and all the rest of it. Not everyone who's searching has flu. Sometimes they're just interested. Sometimes they know someone who is showing those symptoms, whatever it may be. But at Google scale, those oddities smooth out. The spikes in flu-related searching, globally and regionally, correlate very strongly to increases in flu cases. And they run slightly ahead of the official statistics. People are doing these searches before they're turning up in their doctor's surgery. This is a predictive tool that can be used to work out what's coming down the line. And you can see from this map, at global scale, it's not particularly surprising, is it? Flu is prevalent in the northern hemisphere, where it's winter. Just look outside. It's low in the southern hemisphere, where it's summer at the moment. That's not surprising. What I don't understand is why Norway and Germany are relatively low. I have no idea. Let's look a little closer. The Netherlands. Now, don't worry anybody, but you see the red bit, the high bit, it's here. So we'll be handing out face coverings later. Don't shake hands with anyone, don't breathe, just leave the building quickly and quietly and you'll be fine. One last example, and again you can see the microscopy type imagery is struggling a little here. It's carbon dioxide. And if the weather allows Fran Bennett to make it from London, you can ask her for more detail about this particular example. But it's a fascinating one. This is looking at the CO2 emissions from a variety of cloud computing data centers around the world. Amazon is the big one that most people tend to use, and most people by default tend to use Amazon's data center in Virginia, which is filthy, coal-powered, very dirty electricity. For exactly the same price on another Amazon data center, you could use Amazon's Oregon data center. Costs exactly the same, far greener. So if it doesn't actually matter which of those two data centers you put your job in, why wouldn't you choose to put it in Oregon rather than the default of Virginia? The greenest of them all at the moment is Green Cloud in Iceland. It runs entirely on renewable energy. The other big green blob is this one. This is Rackspace in the UK, who actually use the same dirty energy the rest of us use in the UK, but they're paying for the carbon offsets. Does that make them green? They're at least recognising there's an issue. But this tool on the Mastodon site tracks these prices changing in real time, tracks the weather, tracks all sorts of variables that are affecting those prices. Where computing jobs can move around, following the sun, following the moon, following the green, whatever it may be, you could use their API and move your computing jobs around, running on the cleanest computing infrastructure as you go. Size, the whole big data thing, size matters. This is, of course, just Lego. This is not a large Scottish castle. We talk about the data deluge, the tsunami, the flood. We use emotive language and emotive imagery. There's too much data. We can't cope. We can't handle it. Therefore, the implication is it's bad and worrying. You see things like this, the cover of The Economist. Despite the name, of course, big data isn't just about size. There was a 2001 report by the Meta Group, which is now part of Gartner, that proposed what they call the 3 V's. Size is only one of them. Volume, size. The implicit presumption that bigger is better. We need more. We need to hold as much data as we can. My project's better than yours because I have twice as much data as you. That never was true. It isn't true now, and hopefully it never will be true. Sometimes bigger just means the value is more hidden. Instead of searching for a needle in a haystack, you're now searching for that same needle in Germany. All you did was make the problem harder. One of the biggest examples of big social networking sites like Facebook, and the sort of statistics bandied around in this space are mind-boggling. 107 trillion emails sent in 2010, 340 million tweets every day, 50 billion pages in Google's index, 82 petabytes in a single Hadoop cluster at Yahoo, 72 hours of video uploaded to YouTube every minute, 15 terabytes of data added to Facebook every day. Big, big, big. It's all big and getting bigger. But the second of those V's is velocity. How fast does something change, and how fast must I act upon that change? I want to show 2 examples of that. The first is in the financial world, where increasingly financial institutions are moving away from sampling risk to actually dealing with it in real time. Some banks are now analysing all of your purchase history, all of your locational information, all of your context at the point you actually use your credit card. They're not going to some abstract model. They're looking in real time at your data while your transaction is passing along the wire. They're making a decision whether or not to authorise as you are actually buying, and getting smarter all the time about context. My credit card company knows that I bought a ticket to fly to Amsterdam. Therefore, my credit card company doesn't need to worry so much about the credit card transaction for a restaurant in Amsterdam last night, because it knows I'm here. We've got a long way to go in this area, but some of the financial institutions, especially in the US, are working very hard with extremely large volumes of data to try and understand holistically what their customers are doing all the time. That might be good, or you might be concerned about where this might lead. Another example, much slower. We've moved away from worrying about seconds and milliseconds to worrying about hours. This is Tesco, and this was an example that I picked up at the Strata conference in London before Christmas. And Caitlin, who'll be speaking next, was one of the organisers of the programme there, so thank you for getting this speaker on. Tesco has always been known for monitoring its loyalty card data. They've done that for a long time. Some of the early work they did with companies like dunnhumby are sort of casebook examples. But they're also leveraging big data techniques to reduce stock wastage. They're saving, they estimate, around £30 million a year in the UK alone, simply by understanding their stock flows much better. They have weather forecasting data that's updated 3 times every day. Implications for 18 million items in their stock chain are analysed 3 times per day, and those orders are changed accordingly. It's warming up, and it's March. It's the first warm weekend. It looks like it's going to come. Lots of people are going to have a barbecue, the statistics would suggest. So let's start ordering in that stock. Or it's a very rainy weekend in July. Let's cut down the stock of things for garden parties and outdoor activities. And by monitoring this data all the time, they're keeping a very tight rein on their stock control. They're ordering just in time from suppliers, and they're holding £50 million worth less stock in their warehouses. That's a massive saving for a company like Tesco. Variety is the third V. Moving from these neatly structured databases to semi-structured and unstructured content of various kinds, like, for example, tweets and Facebook posts. The usual example are the security services, looking at your activity online in all its various forms. But there are actually more interesting examples, and examples as well where companies are more able to talk about what they're doing. And one of those is in the area of customer support. Here's Dell, for example, and you can do the usual things. You can monitor sentiment on social networks. You can mine sentiment and insight from customer forums, but you can then go further, and you can start taking that sentiment and taking that customer contributed content on your forums and use machine translation techniques to translate that and provide it to people in less well provided for languages. So Dell, for example, is taking language from English, French and German language forums and translating it into Dutch and Danish and other languages, particularly in Europe, to provide support to customers who otherwise wouldn't get it. Because Dell can't afford to provide all of its own content in all these languages, and the customer forums aren't big enough to have that large body of material available in those other languages. People increasingly talk about a fourth V, value. Imagine all those conversations on the golf course now turning into a competition about who is the largest database back in the office. We need to get past that and understand where the value lies. And very timely and topical, this was Dilbert just last week. And yes, indeed. Just want to move on very quickly to this notion of personal information. A huge opportunity lies in mining the connections within massive databases, but also in connections between different silos of information. We've seen examples, for example, like Amazon's, customers who bought this also bought that, mining behavior within a single database. And this, Google, the search index becoming more contextually aware, more personalized, but still mining at scale to understand how my behaviors, my expectations might relate to those of people like me or not like me. We heard this example last year, very widely reported that Orbitz had discovered, Orbitz the travel site, Mac users spend more on hotel rooms than PC users. And there was a huge outcry, massive misunderstanding. You know, the people believing that what this said was that Orbitz was selling more expensive hotel rooms to Mac users. You know, the same room, this one here, because you're a Mac user, I'll charge you $400 instead of $296. That's not the case. That's not what was happening. It's never what Orbitz said was happening. What they said was that Mac users tend to buy a more expensive room. They tend to go for that one rather than that one. That's quite a useful thing to know, actually, because if I can detect what computer you're coming in on, maybe I should move the more expensive hotel rooms higher up the list so that you see them first, so that you're encouraged to carry out your almost involuntary behaviour to spend more money. That's a good thing, actually, for a business, and it's not preventing those users from reordering the hotel rooms by price and picking a cheap one. It's simply using the data to understand what's going on. Thank you.